I'm Darius Salazar.
I'm Trey McAllister.
Patrick Youngers.
And I'm Janelle Sanchez. So we just answered the who. So the what is a 2-liter bottled rocket. When is December 1st. Why for Mr. Cutting's physics class. How. Okay, so we used several sites to find what we needed to construct our rocket. So we found many different types of websites and different types of models that we can use to build our rocket ship, but I believe that Instructables has the best format because it's the most clear and it's actually very simple for us to analyze how to do this and to build our rocket. So here's how our rocket's going to be set up. This is going to be our 2-liter bottle, and we're going to keep the amount of water consistent, but we're going to change the amount of pressurized air that we enter into the bottle. So we're going to have styrofoam fins. Our nozzle is going to be right here, and we're going to use another soda bottle to make the nose of the rocket. Okay, so here are the materials you'll need. You'll need 2 2-liter bottles, cardboard from a shoebox that you'll cut out and make fins. In this case, we made 3. Duct tape to hold everything together, and a weight to place inside of your rocket. You'll also need to cut out the top of one of the bottles to make the nose of your rocket. Okay, so what you're supposed to do first is you're supposed to take your weight and secure it to the bottom of your first bottle, but we didn't realize we forgot this step until later. So you'll take the nose of the cone and place it on the bottom of your first bottle, and you will secure it with duct tape. After your nose of your cone has been secured, you will then attach your wings. We cut out and attached 3 wings, and we thought this would be the most beneficial. This is our final product. We secure the nose, we have our weight inside, and our 3 fins on our rocket. And weigh our rocket with our rocket on one side and a 200 weight on the other. So to balance it out, we place our weight at 18.5 centimeters and our rocket at the 70 centimeter mark. And this is the format that we use to calculate our mass. So what you're going to do is you're going to take where your rocket was placed. So ours was placed at 70 centimeters, and we're going to subtract 50 from it because that's where our middle point is. And we're going to multiply that times our unknown mass, which is the mass of our rocket, and then set that equal to 50 centimeters, which is the middle, and subtract where the weight was placed, which was 18.5 centimeters, and multiply that times 200, because that's how heavy our weight was. And then when we do that, we will get 20 centimeters, multiply that times our unknown mass, set it equal to 31.5 times 200. And then after you do that, you're going to divide both sides by 20 to isolate your variable. So then when you divide that, you would get an answer of 315, which is the mass of our rocket. So as you can see here are the graphs for potential and kinetic energy, and then here are your 3 charts. And here are the graphs for your displacement and your acceleration and your velocity. And here's your kinetic energy and your potential energy graphs for the 120 psi, and here are your charts. So for our conclusion, our hypothesis was correct by saying our rocket's flight will launch faster and higher when we increase the amount of air pressure in the bottle and keep the water level constant. So the phenomenon in this project is when the rocket is launched and the water trails and follows it rather than going straight to the ground.